Okay, hi. Welcome. Sorry for the technical difficulties here. Uh, Welcome to the Play MySQL with Ansible and Vagrant. My name is Daniel Guzman Burgos. Here is Robert Barabas. Um, okay, before we begin, um, how many of you know any of these words, Ansible or Vagrant? Oh, okay, awesome. Okay, so let's start. Okay, this is the agenda. We're gonna do some basic introductions um, about the whole thing. We're gonna talk about the environment setup, which is um, all the things that we need for a successful deploy. It includes something about VMs, virtual machines, uh, some little things about Git, and of course Ansible. Then we're gonna move to Ansible insights, uh, terminology, concepts, and at the end we're gonna build an Ansible repo. So there are our emails. So let's begin. Um, this presentation has a tutorial that is already on Git. Um, that's the address. In case we cannot cover all in deep knowledge, you can go there. It's pretty well documented. There's not only a tutorial, but also a demo that you can easily run. So I will advise you that if you want to go with more deeper knowledge, hit that GitHub repo. Okay, that's the same. Check out the repo. Okay, let's start with virtual machine setup. For the ones who don't know, we're using something called Vagrant. Vagrant, it's like a wrapper of around VirtualBox, AWS, virtualization tools. For this case, we are using VirtualBox. So the ultimate goal of Vagrant is to make it easy to manage VMs, configuration, launch the VMs, networking between the VMs, everything easily configured and also easily to share with Vagrant. The core of Vagrant for configuring VMs, virtual machines, it's a file called Vagrant file, which it looks like this. It's Ruby syntax. Basically, the good thing with Vagrant is like for all is in here. Can I move to? Okay. Yeah. Okay. So do we have? Oh, okay. Um, so the VMs that we're using for this talk, for this tutorial, it's just gonna be two VMs. One that will act like a MySQL master, and the other as a slave. And all is defined in here. The key parts of the background of this Vagrant file is first the box, which is this part. What's the box? The box is the operating system, the machines like an AMA that we're going to use. That is going to be the source of the all VMs. In this case, the box is a CentOS 7 box that it's gonna be downloaded from Vagrant Cloud, and that's one time only thing that is gonna be downloaded from cloud. You don't have to put an URL or something else. If you're using a box that it's already on background cloud, um, that that box is gonna be downloaded just once, and for subsequent VM runnings, it's just gonna make a clone of the box, which will be like the second step. Um, and continue with the file. Um, we're defining actually the two boxes, the master and the slave, um, and it's easily as defining the IP and the host name, and that's it. So this file, instead of sharing a configure VM or a BDI file or a big file, you just can share this simple file and make sure that everyone else is going to use your exact virtual machine.
Can I interject?
Yeah.
I'd like to interject a couple thoughts. I like to interject things into networking too. But the ultimate goal of what we are trying to achieve here is basically pull up some miniature infrastructure, right? And then that will allow us to basically develop our own Ansible builds against it, and hopefully that same build, that same project that you build can then be used in production, to really provision your environment. And in our case, this is just the proverbial, doctor's horse, where you are, really just indicating the features, the ideology of Ansible, on how these Ansible projects are usually built. As you will see, we will, go through that really quick. Ansible is basically a language that is fairly modern. It was basically established in 2012. So very modern language. They have, obviously used some of the previous experiences of other projects to, basically deal with configuration management at the infrastructure, and then later extend that to other levels. It is a perfect tool if you have, old-fashioned bash scripts or other scripts to automate those tasks and kind of make it idempotent. Idempotency, as you will see, is a key factor when you use Ansible. So making sure that you can rerun the play, or as you will see in the terminology, that's how the orchestration plan looks like or sounds like, is repeatable. We will want to describe, instead of commands, we want to describe a state that we want to get to, and that's the key, in the mentality of Ansible. Now, as we get into the nitty-gritty of this, and if you go to the GitHub site, in the tutorial sections, you have all these markdown pages that describe how to install, Vagrant, how to install Ansible, how to do a basic Git configuration. Basically, all the components that you need that will enable you to start developing your playbooks. You go to the website and execute those commands. They are really detailed. It will provide you with a framework that should just work, and that will enable you immediately. Now, given that we have somewhat of a Wi-Fi bottleneck here in the conference, we have a couple local repos as well. So instead of you going out there checking out, and again for Vagrant would just basically pull down a vanilla OS image and start provisioning your VMs with it. Instead of doing that and pulling down that 350 meg VM image, we do have them locally provisioned and a slightly modified Vagrant file that points to that local instance. If you guys are curious or you want to hack away while we talk, I have 3 pen drives here, among them Flash. If you guys would like to, please come and get them and check them out. So this also has modifications that affect the package repositories on the local virtual machines, and the packages will not be downloaded then, right? So please go ahead. There is a tarball. Just extract the tarball. There is going to be a directory called Ansible tutorial. Inside that Ansible tutorial, you will find the structure that we talked about. The demo directory is going to be our Ansible directory. That's the one that we are developing, okay? So you have all the end results there. You can run it as is. You don't have to do much with it. If you'd like to repeat that, then create another directory and just follow the steps of the tutorial to build it up to that point that we have it. Okay? So, yeah, go ahead. Question? So the question in the room was, does Vagrant work with VMware? It does, but Vagrant has plugins, and one of the plugins, the VMware plugin for Vagrant, is actually licensed, I think. So I think even at this point, it's you still have to pay for it. The company behind Vagrant is HashiCorp. It's a Ruby application that's scrambled or encrypted. Unnecessary info. Okay, sorry, and that's what we have here on the Vagrant file is that basically it would go out, if you just put it in as is, it would go out to the Vagrant cloud and fetch that base image. So the file that we have on the pen drives is actually modified to use a local Vagrant box, which you can also manually tinker with, add it to your local stash, okay? So let's try to avoid that, or else it will take you forever to go through the steps of the tutorial.
It's okay.
Okay, so but where we would like to be is that everyone has the components installed. What are the components? The components is VirtualBox primarily because it's a free, user space virtualization for you. Well, somewhat user space, some kernel modules. It's a free virtualization tool. Vagrant is the orchestrator that will manage your VMs. So with that, you can easily bring them up, crash and burn, test them, easily provision just the base VMs themselves. As you might have seen, there is no provisioning defined in this file. It's really just responsible for bringing those VMs up, assigning an IP address and a host name to them, and that's it. You could theoretically immediately, within the Vagrant file, not theoretically, practically, define your Ansible place that you want to run against those VMs and provision them as basically Vagrant has this provisioning step that it could execute, okay? So inside the Vagrant file, you would have configuration options for the VM, and you could assign a playbook to the VM to provision it up to par, okay? So that's feasible. We are not doing it because we are separating the two things. We're basically trying to provision a play that can work against virtual machines or our physical hardware. We are just using Vagrant as the means to give us a lab, okay? So the GitHub repo, if you haven't checked it out just yet, you should, not because of the awesome picture, but because of the tutorial link that basically will have all the links to how to install VirtualBox, how to install Ansible, how to install Git. So this is what I was referring to. It's all markdown pages. So if you go there, again, repo name, and then basically /tutorial, it will provide you with installation instructions and link to the installers on how to do it. We normally just use Macs. Many of us do, or Linuxes. So with most of those systems, it's a one-liner to install these. If you are using a Mac, I would recommend Brew and Cask. Brew is basically a Mac package manager in lieu of a better word. Cask is basically an extension to it, an interface that will allow you to fetch installers, and instead of clicking through the installer, it will allow you to quickly provision them. So in an ideal case, you could provision your base infrastructure by just running brew cask install Vagrant, brew cask install VirtualBox, brew cask install, can you guess what were the others? Git, right? And Ansible. And then you're done with the setup. So that will provide you with the tools that you need to develop, okay? Similarly, you can use apt-get, yum. You might have to tinker around with a couple repositories. It depends on the operating system of yours, whether they have explicit repositories, EPEL, that extend these. But that's what you need to install in order to proceed with the tutorial. So Vagrant, VirtualBox, Git, and Ansible. Once you install them, we will be at a point where we can pretty much test the VMs, right? You have the virtualization software installed. You have the orchestration tool, Vagrant, installed. And then you have Git installed, which will help you on the long run with the configuration management, right? You will be able to track your changes. At that point, we would like you to basically fill out that Vagrant file or use a Vagrant file similar to what you see on the pen drive, and pretty much bring up the VM. So I'm gonna switch back to the slide and switch back to our old Vagrant file, and hopefully even hit play in a successful way. And what you would do at that point is you would create a new project directory. That's your own project. Create this Vagrant file inside. This Vagrant file, as my educated colleague describes two VMs. One is called master, the other one is called slave. Assigns static private IPs, so they will have their own little private network on your laptop that they use to communicate to each other, statically assigned. There are obviously ways nowadays to do dynamics, but we just needed a simplistic environment here. And once you have that descriptor, this Vagrant file, on in your project directory, we would like you to do Vagrant status and Vagrant up. Okay, so that would be the trial of the test. If Vagrant status comes back and has a meaningful description, that means that Vagrant is properly installed. I think in this directory, and I'm not a lefty, so it's gonna get interesting. In this directory, we have a Vagrant file. This is a Vagrant file similar to what we have. That offline there doesn't, indicate my status, although I'm kind of offline. It indicates the branch of the GitHub repository that we wrote to come up with a modified infrastructure. Increase the size, yeah. Okay, so this is basically the box name has been changed so it doesn't conflict with Jay's virtual box image, and the box URL basically points to a local file. So instead of going out to the Vagrant cloud, we're just going to include the image that was on those pen drives. Okay, so but this is again a descriptor, right? The action happens when you run Vagrant status and Vagrant up. Vagrant status doesn't do much. It just basically does the syntax checks against the Vagrant file and make sure that you haven't had a typo. That's why I said it first. And you should see that, I still have them running from a previous case. So we will do Vagrant destroy -f to quickly destroy them. We always like this part, right? Okay. And after that, I will have two VMs in a basically not running case or not created case. Okay, so at this point the VMs are not provisioned, they are not running, no networking, nothing. We cheated a little bit because if we do Vagrant box list, we can see that I have already imported these boxes. So one of the keys is that you will have basically your virtual image to provision these, right? Just kind of akin to VMware and VMware templates. You basically have these base VM images that you will use to provision them further. So I have already imported the VirtualBox image from the pen drive, but when you run Vagrant up first, it will, depending on what branch of the repository you use, it will either import the local Vagrant image or go to the cloud and fetch the Vagrant image or the VM image from Atlas Vagrant Cloud. Okay? So here we are upping the machines, they are being started, and if you do up, it can provision them as well. Again, we are not provisioning them, we explicitly separated that step out, but normally when you have a virtual environment, a virtual lab that you're trying to use to hack those virtual machines or test out solutions, you would do provision them automatically. It runs them one by one. It uses SSH to authenticate to these VMs. And these VMs are prepared specially. They have an insecure key. So that key is going to be changed. There's usually a default user Vagrant. So if your key for some reason is garbled and it doesn't work, you could try to SSH to these virtual machines with the name Vagrant. Now, how do you SSH to them? They're running on they are accessible through localhost, and as you could see that once you start up one instance, the default port will be taken. So the second instance will have a remap name, but you don't have to necessarily remember these Vagrant abstracts that information away from you, and you can just run vagrant SSH and the name of your VM from the directory that contains the descriptor file, vagrant file, and it will, hopefully be able to SSH successfully. And it did. We have two interfaces on this VM. One that does a network address translation and allows my VM to talk to the internet through my host. The second one is the private IP address. That's what we will use to simulate replication and such. Okay, so who in the room is doing the exercises at the moment, or is there anyone who we should wait for, or any questions so far? No? Okay. Well, once you do, you should test this one just to make sure that your infrastructure piece is working. Okay, make sure that you can up those VMs, they become running, and then make sure that you can access them through the Vagrant interface, and as you will later see explicitly through basically SSH. That's how we will set up Ansible to access them. Okay, so just for the good habit of it, we will set up Git. We use primarily Git with Ansible, or in 99.9% of the cases I've seen Ansible used, it uses Git. Ansible has two different operation modes. In both cases, we prefer to use Git. One is the Git push. That's what we will be most familiar with. That's when you have a management workstation, and that's what you use to push out changes to the boxes through SSH. You don't need to go ahead of, you just go back to the git config. So inside git config, you just have to come up with a basic configuration. You have to set up your username, your email address. That's just for the commit, or else you will be asked to do that when you do your first commit. That's configuration management. We are not really going to use configuration management at this point. When you use pull mode is the kind of mode where you have this Ansible repository on a Git server, and all your servers pull the changes down and apply them, kind of like how Puppet or Chef or some other tools use it, if you are familiar with those. So in those cases, your servers are pulling the global repository and try to apply those changes as they come, usually by using a scheduler such as cron, or some other enterprise ones as well. Once you set up your GitHub account, at this point you have those two VMs up and running, right? You then can start basically defining your project. So inside your project directory, what do we have at this moment? We have the project directory, which I call demo, a Vagrant file inside that's just for the infrastructure to describe it, and then we define our real Vagrant environment. Vagrant uses terms such as inventory files or inventory. Sorry, not Vagrant. Ansible. You're right. Thank you, sir. Thank you, sir. So Ansible uses terms such as inventory, such as management workstations, such as managed nodes. So normally, when you use push mode, so a management workstation is what you sit and store your repository at. To provision these VMs, the managed nodes, these VMs are grouped, and they are described by something called an inventory file. I think in our example, we call that inventory file hosts pretty simplistically. And maybe on the slides, we can show them the example, the simplistic one. In this particular case, we will have two simple groups. One will be called master, the other one will be called slave. Groups are kind of like labels, or kind of like encapsulation around these hosts. We will, in each of these host groups, we will have only one host. In the master host group, master, and in the slave group, you probably have guessed, slave, right? And we will also define another group called all. That's just to encapsulate all the servers that we want to manage, and these are going to be the groups that we use in our examples. Okay, so far so good? Good. So inventory just describes your infrastructure and groups your servers. Now that groups your servers into, your logical groups. The servers will also have roles. Roles kind of define what the servers do or what characteristics they have. Okay, so I can have a role that does separate the operating system baseline provisioning and does it in a certain way. And it can have a role that specifies it as a MySQL server. Okay? So among the groups, both master and slave could be a server that does a hardened, that assigns a hardened operating system role to each of those servers, and also assigns MySQL server as a specific role to these servers also. Okay? I usually logically separate the application piece from the base operating system piece, and still separate the infrastructure from the application management piece, but your mileage may vary. You might consider doing it otherwise. Oh, okay. So these are roles. Roles basically are there to help you reuse the code. You don't necessarily have to define roles. There is something called tasks that are basically the equivalent almost to your old-fashioned shell commands. So let's say you had a bunch of servers, like we do here in the Vagrant environment, right? You have these VMs out there, and you would normally run, let's say, a shell script to update packages, to fetch packages, to put some configuration files on those servers, maybe to generate a server ID, and so on and so forth. So all of these tasks are, as I said, tasks, right? Previously, they were, basically shell script commands. Now you are trying to achieve these steps as milestones, quasi. So tasks themselves, ideally, should be idempotent. What do I mean when I say that? I mean that when I say I want to copy, instead of saying I want to copy this file from my management workstation over to the node, I want to say I want that file on my management node and do whatever it takes to deal with it. That's the ideal, right? And that's what ideally that task should achieve. Now, when the task does that, through so-called Ansible modules. Okay, so Ansible modules are essentially the words of the language. If you think of Ansible as a pseudo language, then those are going to be your words. So when I say, that I have a file and I want to copy that out to the server, I'm going to use a task that employs the copy module of Ansible, and it defines what file to put where, with what kind of permissions, and I can define additional attributes. So far, so good? Yeah, go ahead. Mm-hmm. So the question in the room is whether Ansible is similar to Puppet. Yes, it is. It's pretty much another configuration management. Puppet is Ruby-based. Ansible is Python-based. But other than that, the major difference here is that Ansible is trying to be idempotent. It runs these tasks normally, sequentially. There are other ways around to deal with asynchronous text execution. But it runs them sequentially on a given host. You can run them in parallel against multiple hosts, but on a given host, your tasks will run exactly as you see them. So it's pretty intuitive, kind of behaves as a shell script. And yes, it is very similar to Puppet. Puppet, I think, prefers, or in most cases I've seen Puppet be used in a pull mode, where there is a central Puppet repository and you pull the changes and you apply them on a, make sure that they get applied on a frequent basis. But this is more of a, hey, push and run, right? Okay, does it make sense? Okay, good. So when you define these tasks, you are employing modules such as, what we see on the screen, first of all, is basically a play. This play describes the setup of my base OS. That's where I wanna, that's what I'd like to do to ensure that my operating system is provisioned in a way that I can use it. It's comfy for me, right? So what do? I said, I give a name to this play, which is setup OS. I define that it should run against the host group all, which contains slave and master. And it defines multiple tasks to achieve, the state that I want. It installs EPEL as an additional Yum repository. It installs a bunch of packages with an iteration. As you can see, there is a list defined there with all the package names. And all I need to use is, hey, I want to install these packages. Yum will figure it out how to do that. I'm going to specify that I want a package named this and that to be installed, and I just want to see it present. And I can run it anytime, multiple times, and it will ensure that those packages are going to be in the state that I defined, which is present. Okay? So far, it's a pretty sequential task sequence. There is no interaction between the tasks. There is just a recipe to execute these tasks, right? So simple case. When I get to the MySQL piece, we kind of added some additional pieces. So we might need to figure out a couple extra pieces and maybe conditionally execute certain tasks. Just for the sake of the demo, it is on the screen and it is written out and there is this interaction between the tasks. But ideally, your task would define, hey, give me a server ID. How do you figure it out? It's up to you. Ansible uses facts and maybe your own generated facts to figure these things out. But you could have a module that says, name, give me a server ID. Module name might be MySQL Server Generator, it's a mouthful. And it would basically yield a result which is going to be a server ID variable that you can use for your MySQL. That's how I would do it in production, and I would write my own fact that generates that ID, secure it so it doesn't collide. In here, it's kind of like stretched out and elaborated as a conventional shell script, into tasks. And because of that, you kind of see an interaction that is characteristic in many cases to Ansible, where you have certain tasks that are obvious, that are kind of stateful, that is going to be obvious on how to deal with. Install that package. If it's installed, great. If not, go and fetch it, right? And in some other cases, how many times do I want to generate a server ID? Hopefully only upon installation, right? So there's some interaction between these tasks where I say when the server is installed for the first time, when I install the package first, then that change should trigger additional tasks that otherwise should be shunted and should not run. So there is a very Ansibleistic way to define these conditions. Maybe down the screen you see these random underscore number filter or pipe changed syntax there that says only generate or only execute these tasks when that condition, the random number changed, is fulfilled, or even before that, only generate a random number when Percona server changed. So when I install the package, that makes sure that although I don't have a module per se that would give me that idempotent operation, that it will still be idempotent, but I have to handle it myself. Okay? So if you have a module, great, use it. It's gonna make your play much more readable. If you don't, well, you have to come up with it and use the filters to make it readable. Readability for these are crucial. Many of the users of Ansible are not necessarily Python programmers or not necessarily shell programmers either. Okay? So here's that. It uses a bunch of other extra modules here that indicate the potential of the language, such as templating. So you could have templated configuration files just like in other configuration management systems, where your configuration file has some metadata content that's filled in, as variables upon deployment. And it also takes care of the deployment of those files to the machines. So you have it on the management workstation. You don't need to explicitly copy it to the servers with an explicit task. It takes care of that also. Okay? Here's the macro for a MySQL configuration file, where we just iterate through a dictionary and add the key value pairs. If there is a value to the key, then great. It's an equation sign that needs to be put between them. If there is none, we just define the key itself, right? So, but that generates your configuration file uses, the server ID and all that fun stuff. Okay, so that would be the second, basic play, right? So we had an operating system play. I separated logically out the MySQL play, and then eventually I will want to think about abstracting that information. Eventually, instead of saying, hey, you run all these tasks against all the servers and seeing that repeated multiple times, I just want to abstract that, call it a name, which name is going to be the role, and then use that role and assign that to the server. So it's easier to say, hey, my master server is a hardened Linux box that runs MySQL server than to say my master server does, fetch the EPL repository, install these packages. When all these packages are installed, it installs, these additional packages. You know what I'm saying? So it's easy to clutter your definition. At its best, your main playbooks should be readable by maybe even like close management, so your immediate management. Okay, so it should be readable. Readability is key. When we talk about the reusability with roles, we have to mention that there is something that's called Ansible Galaxy. That's basically a repository that others also use to submit code. So if you're thinking about like writing your own roles, writing your own tasks, maybe first check to see if there's something that people have developed. And you could already pretty much see a MySQL server role out there that you can just configure and use. Okay, so instead of you having to write the bash script, you having to write, your own ideas, you could use, the Ansible Galaxy to fetch that. We used Ansible Galaxy and the command of Ansible Galaxy here to generate a definition, a structure of a role, and that created the structure that we need, the directory structure, and then we just push the previous elements of the plays into their places. Okay, so that's what happened here. As I'm getting close to the end of our time, why don't we jump to the very end of it? There are two additional plays in this tutorial that you will want to check out. One basically is responsible for fetching the Sequila database from Oracle, download it to the box, and then import it on the master node. You will see that that play only runs against the master node. And there is another play that gets a little bit more complicated that I would only be able to explain when we would have a little bit more time. And in that particular case, we are doing a extra backup streaming copy from the master server to initialize the slave. So with that, we populate the slave server with data, and we parse out the pointers from the extra backup configuration file and automatically set up the slave to replicate from the master. Now there are a couple of tricky pieces in there that that basically demonstrate the asynchronous features in Ansible, where you could block and in some cases not block execution. For a play like the last one, where you do the streaming replication, you will have to first touch the target, shut down the MySQL server, empty out the directory contents, then basically start up a network listener that will receive the data, right? That's on the receiving end. But you have to send that receiver into the background with a real asynchronous Ansible process, okay? Async option, colon, and then the number of how many seconds you want it to live. So usually it's a good idea to, end that process eventually, in case you'd never send any data. And then once the target is prepared, your source can run extra backup to stream that backup and populate the slave server, right? Once that streaming completes, your previous asynchronous task will complete. We just have to trust it. You would find that in the logs, but again, you kind of sent it into the background as if it was a job. And once that happened, you can then basically start working on the receiving end again, parse out the slave coordinate or the coordinates for the master, for the change master command, and then start up this MySQL server and just issue the change master to command. Okay, so and all of these pieces are in place. You have all those roles defined, or you have all the building blocks to your infrastructure. You will want to just create a site-wide playbook that basically provisions the entire environment. That can come handy even as a descriptor, and in some cases it can it can come handy when you need to provision entire environments. So the other outcome of the playbooks that you have here is a site YAML that includes not like as in literally includes all the tasks, but it sources them in, includes all these tasks to essentially run the playbooks in a sequence. You know, when you bring up your VMs, it will run the OS setup, the MySQL setup, the Sequila import, and the replication setup all at once. And with one fell swoop, you can provision these VMs. So at at the very end of this, you could modify your Vagrant file to include perhaps a play that does all of that, right? The site YAML. And it could provision your VMs as is, okay? So in the end, you pretty much bring up an environment that is replicated, that has a database on it, that has maybe users added, that can sing, you know, beautifully with one command, which would be Vagrant up, okay? I think unless we have like detailed questions or any questions in the room, I think I'm done. I don't know. Did you want to add something or? I mean, I apologize for the hurry. We kind of get a late start, and I have to check my display driver, I assume. So, but if there are any questions, we are gonna be hanging out here for a little while. Come and get us, or get us. Yes, GitHub us. And otherwise, thank you and thanks for attending.